This video is about logic. I'm going to tell you what logic is and how mathematicians think about logic and what are we going to do in this chapter in the book. So, what is logic, or more appropriately, what is mathematical logic? Uh, One very simple way to think about logic is it's just a new language. So it's a new language that's used in math, but then why do we need a new language? Um, we need a new language because it's very precise and unambiguous. This is very important in math. We need our statements to not be open to repetition, to have exactly one precise meaning. And the natural languages like English or French or Chinese or any other natural language that we use for speaking is often ambiguous. A single statement can mean multiple things, and it's not precise. Like you might need a lot of words to convey a statement, and that's not ideal for math. And so we created a new language, which is called logic, that we use for expressing math. No matter, like even Newton's math that was written like 200 years ago or 150 years ago is still valid. Like every statement still makes sense, and you can test whether it's correct or false. Whereas this is not true for, like, say, law, which was written 100 years ago, and now it's not clear what that means. So that's why that's why we study logic. Okay, and we need a few definitions to start with. Oh, before I go to definitions, another reason why logic is very useful is that computers can understand logic very well. But you cannot say the same thing about natural languages. Like even now, computers can barely understand English. They're getting better at it, but they're still far off. Whereas they understand logic really well, as we'll see some examples of this. And so that's another reason why we care about logic. All right. With that being said, I need a definition to say more about logic. A proposition is a statement that can be true or false. And in English, let's say, it's a statement that can be true or false. For example, let's say 2 + 2 = 4. You can also say something like 2 + 2 = 5. The first statement is true. The second statement is false. And because I can assign a true or a false value to these statements, I'll call them propositions. Non-examples, something that is not a complete statement, like 2 + 2. This is not a proposition because it's not a complete sentence. I can't assign the truth or false value to it. It's just an expression. It's not a statement. Another example is, let's say, what time is it? I cannot assign either true or false to this statement. The true or false are called, these things are called truth values. So the statement 2 + 2 = 4 has the truth value of true, and the statement 2 + 2 = 5 has the truth value of false. Okay, with that, now I can tell you a little more about logic. The central question of logic is to determine whether a proposition is true or false. And that's it. That's what drives all of logic. That's what drives all of mathematics. We try to prove something is true or something is false. And because logic is precise and unambiguous, I could say we are trying to prove something's true or false without any doubt. So that's what we're trying to do in logic. Now, one last thing. What are we trying to do in this section? We're trying to do something slightly different. It's not exactly determining whether something is true or false. So for this, I need one more definition. A compound proposition is a proposition made by combining simpler propositions. For example, I can say something like 2 plus 2 equals 4, but it does not equal 5. So here is my first proposition. Here's my second proposition. And in the middle, I have a connector, which we'll talk about in the next video, that connects these two propositions. So this is called a connector. Actually, this is called a logical operator. It's not precisely a logical operator, but for now, we'll live with this. And so that's what a compound proposition is. And now I can tell you what we are aiming to do in this chapter, in this book. So our goal is slightly different from the central question in logic. Our goal is to determine the truth value of compound propositions given the truth value of the simpler ones. So in the above example, if I know that the proposition 1 is true and proposition 2 is also true, and from this I can say that the whole compound proposition is true. And this is the yoga we'll do in this entire chapter. Given simpler things, how do I conclude something about a more complex thing? And this is a very useful skill that you'll need throughout this course or throughout all courses of mathematics or science. Given some simpler facts to be true or false, what can you conclude about a more complicated fact? That's introduction to logic.